Alright, so we'll start a new lesson today. Today is going to be section 9.3. And I have a lot of good things for you today. So let's take a look. Today is April 2nd. And we're going to be talking about how to reduce. This is section 9.3. We're going to be talking about how to reduce, multiply, and divide rational expressions. And this isn't a hard thing to do. I mean, there's a couple rules we're going to keep going back to. We always want to make sure we know how to factor. I told you all along that's the most important thing in math. And the second thing we're going to make sure that we do is if we're dividing, that means the same thing as multiplying by the reciprocal. Also, if we see the same factors in the numerator and denominator, we could cancel them. So these are all things that we know. Let's just get right into some of these problems. Directions for today are just going to be to simplify. First problem, 30xy divided by 12x squared. Sometimes what I do is they're all being multiplied together, so I could just write similar terms and factor this way. And some people would just take out a factor of x, take out a factor from here, make 1, and you could do that. Some people call that cross-reducing. I found the most success with this. So 30 over 12 reduces to 5 over 2. Anytime we're dividing the same base, we subtract their power, so that would just be x to the negative first. And just combining all of these would give us 5y over 2x. Remember, 1 minus 2 would be x to the negative first, which is why that wound up on the bottom. Let's try something else. How about this one? C plus 5 divided by 2c plus 10. Now, you definitely don't want to simplify these. You're adding the whole denominator. Remember what we always say. You can't break up a denominator unless it's multiplication or division, like the last problem. If it's over addition or subtraction, you have to leave that denominator alone. One thing we could do is we could factor out a 2 from the bottom, and then those cancel, and you're just left with 1/2. Well, it's pretty easy. Please don't ever separate a denominator over addition or subtraction. That's a really bad mistake. All right, what if we had something like this? A minus b over b minus a. Now they look pretty similar. One thing we could do is we could rearrange them. And actually, if you see, the bottom, the denominator has a negative 1 in front. It's actually kind of interesting. If you take out a negative 1, you get a minus b, and then they could cancel. So this, when it's all said and done, just turns into negative 1. So if you ever see subtraction and it's almost the same thing, like a minus b over b minus a, factor out a negative 1, write them so the same terms are in the right order, and take out a negative 1 and you should be able to do it. What about a problem like this? 6m minus 30 divided by m squared minus 3m minus 10. Well, let's factor first. Factors of negative 10 that add up to negative 3 would be negative 5 and positive 2. It actually gets kind of fun once you start canceling everything out. That's what we get. How about one a little bit harder. How about this one? 3a to the third minus a to the fourth divided by 2a to the third minus 6a squared. Now please don't do this. You have addition and subtraction in the denominator, so you're not allowed. But what you could do is you could take out an a to the third on top. You could take out a 2a to the second on the bottom. And remember what we said before. These are very similar. If we rearrange them, you could see we could take out a factor of -1 on top. So we just really factored. That's the main idea. We keep going back to that. And actually, at this point, we have -1 over 2 times a to the third over a to the second, which would just be 3 minus 2 is 1. So -1/2 times a is just -1a over 2. You don't have to put the 1 if you don't want. So that should take care of those kind of problems. What about if we're multiplying? Those are just single fractions. What about if we had a problem like this? Let's say x squared minus 9 over x squared plus x minus 12 times x plus 2 over x plus 3. Well, one thing we always keep going back to is factor. So let's go ahead and factor everything. You're multiplying the fractions, so I could just write it like this. X squared minus 9 is x plus 3 times x minus 3 times x plus 2. Right? We're multiplying fractions, so we just go straight across. I could write them together. At the bottom, this would be x plus 4 times x minus 3 times x plus 3. It's kind of neat because these are the same, and we're just left with x plus 2 over x plus 4. We can cancel out these factors because there's no addition down here. All these terms are being multiplied together. If we're multiplying and dividing by the same factor, we can cancel them out. How about a problem like this? 2a squared over 5b squared c times 3bc squared over 8a to the third. So one thing I would do is I would multiply the numerators, multiply the denominators, and then rearrange them so the letters are all in the same spaces. So the top would just turn into 6a squared bc squared. The bottom would turn into 40 a to the third b squared c. If we do each one individually, 6 over 40 is just the same thing as 3 over 20. A squared over a to the third is just a to the negative first. B to the first divided by b to the second is b to the negative first. So I'll put those in the denominator. And then c squared divided by c is just c to the first. So as far as our final answer would be 3c over 20ab. And we'll do one more of these. What about this one? How about if we had c to the third plus 3c squared over c plus 5 to the second times c squared minus 25 divided by divided by c squared. First thing I would do is I would factor out completely, including this one. I would just write it twice. So I could take out a GCF here of c squared, and and then I get c plus 3. I'm going to be multiplying that with this difference of perfect squares. C plus 5 times C minus 5. Then on the bottom, I'm going to write C plus 5 squared twice, just to make it easy for me, and then times C squared. Well, these C squareds cancel. One of these cancels with one of these, one of these cancels with one of these. When it's all said and done, we just get C minus 5. So I hope you're enjoying this as much as I am. This one is, let me see. You know what? I was looking, I think I might have made a little mistake.